Alright folks, it's Coach Curtis here again, giving you some more help with some exponential functions using a couple of particular examples. Now with each one of these little sessions, I'm going to highlight one specific part of the original problem, either the a, b, h, k, or even the x, that is going to affect how this graph looks. But for today, the only thing that I'm going to mess with is going to be the base, or b. Now, with the base, you can have two different options, one of which is going to be a value greater than 1. And the other thing that we could be dealing with is the opposite, where b was greater than 1. Now it could be less than 1. Now I'm going to work through each one of these individually and then compare the two together so that you can see the difference depending upon the base. What we've got here is y is equal to 2 raised to the x power, okay? And what we want to do is we want to take a look at our original form equation and begin to identify the parts so that it can help us with our graph. So let's take a look first. The easiest thing to start with is always going to be the base, b, which is real easy because it's whatever number actually has the exponent. So here, the base is 2. Now a, the number out front, is going to be whatever is multiplied times the base. Now essentially I've got a 2 and nothing else, but because it's multiplication, it's now understood to be 1. Now I move on to the h and the k. Now h is being subtracted from x up here in the exponent. I don't see any number, and when you don't see a subtraction, that's really a 0. And then lastly, when I move on to the k at the very end of the problem, I don't see anything added or subtracted at the end of this problem. So to add nothing is to again add 0. And now that I have each of these parts, I can begin to use them to come up with my graph. Okay, now that we've got our parts, let's actually put these things to use. Now the two things that I need in order to graph an exponential function are going to be my initial point found using h and the sum of k plus a, as well as my asymptote, okay, that boundary line that the graph never actually touches. So, for the initial point, I need to find an ordered pair, okay? The x value is going to come from h up here. So my x value is going to be 0. Now to find my y value, I'm actually going to take a and k and add those two together. So now I've got 1 plus 0 equals 1. So my initial point will be at 0, 1. Now for my asymptote, I'm going to find this using the equation y is equal to k. So I can go ahead and put the y equals, because that's always going to be the same. And then I just need to look at my equation, okay? K, the back number, was a 0. So my asymptote will be along the horizontal line, y is equal to 0. Plot these points, 0, 1, and a horizontal asymptote right through that x-axis. Then I can graph the rest in just a moment. Okay, now to complete this graph, I need to figure out what's actually going to happen from this initial point as I move to the right and from this initial point as I move to the left. And the way that I'm going to do that is to use an x and y table. So there's one point I already know, and that's going to be the initial point at 0, 1. Now as I move from the initial point to the right, I'm going to pick an easy number, okay? If x was 0, now x is a 1. I can find the y later. And if I start at 0 and I want to figure out to the left, I'm going to pick another easy point. So I'm going to start using a negative 1. I can find the y later. Now, if I plug negative 1 into my original equation, 2 to the negative first is going to be flipping the base of 2. So it's actually 1/2. And then if I plug in a 1, 2 to the first power, anything to the first power is itself. So in this case, plugging it back into my equation, I get 2. So now I've got both of my points. So I move back up to the graph and I find the point 1, 2, plot that point, and then I also find the point negative 1, 1/2. And now that I've got both of my points, all I'm going to do is to connect the curve by leveling out as I get closer to the asymptote and getting steeper as I move away. Okay, now I'm going to work with another example, except this time I'm going to use a b value of less than 1. So in my case, I've got 1/2. So taking a look at this problem, the base is 1/2. And I don't see any other number out front. So because it's a multiplication problem, it's going to understood to be a 1. Looking at the h, there is no other number up in the exponent, so if I subtract nothing, I subtract 0. And then looking at the k, there is no number at the back, so if I add nothing, I'm adding 0. And all I have to do is to take these points and plug them into the parts. Alright, now that I've got each of these pieces, I'm going to plug them in where they need to go. Now to get to my initial point, again, I need h and k plus a. So I'm going to start with the h value, which is easy, 0. So that gives me the x value of my initial point. Now I'm going to take a and k and add the two together, so that way I have my y value. 1 plus 0 is a 1. So again, I have 0, 1 for my point. Now as I move down to the asymptote, again, it's y equals k, and this is going to give me a boundary line that my graph will get really close to touching, but never quite reach. So we take a look. K is equal to 0, so that means that my asymptote will be along the line y is equal to 0. And as I begin to plot these points, my initial point is going to be at 0, 1. And my asymptote will be along the x-axis, or a horizontal line, at y is equal to 0. Then all I have to do is come up with the rest of my graph. Now to find the rest of my points, we're going to handle it just the same way that we did here. There's one point I already know, and that's going to be at 0, 1. But in order to figure out what the rest of this graph is going to look like, I need to figure out what's going to happen as I move to the right and what's going to happen as I move to the left. So I'm going to pick one value to each side. To the left, I'll pick -1, and to the right, I'll pick +1. And then plug each of these values in to figure it out. Now watch what happens. If x is a -1, that means I have 1/2 raised to a negative exponent. And anytime I have a fraction raised to a negative exponent, it flips. So instead of 1/2, it's now 2 over 1, so just 2. Then, if I plug in a 1, anything raised to the first power is itself. Every single time, no ifs, ands, or buts about it, hell or high water. So 1/2 to the first is just 1/2. Now that I have these 3 points, I can graph. So I go to -1, 2, and I also go to 1, 1/2. And now that I have both of these points, I can continue to draw my line, flattening out as I approach the asymptote, and getting ever steeper as I move away from it. Now that I've finished with both of these graphs, you'll notice that each one was done the exact same way, and with one small exception, they look almost identical. So watch what happens. As I move from the left to the right in this first example, my values along this curve increase, okay? They increase with respect to x. Anytime this happens, we're going to call this growth. Now, as I look at my second example, as I move from left to right, my curve actually finds values that decrease along y, okay? So again, with respect to x, my y values decrease as they go on. We're going to call this decay. And so the rule of thumb is here, if your base for your original problem is ever a value greater than 1, then it's automatically going to be a growth problem. Also, if your b, your base for your original problem, is ever a value less than 1, then it's always going to be decay.